Done, started. And now we just need someone to verify that we exist, to confirm our reality, to
I
make
love
an
how they're
observation.
so. Will they be on time? Will they
Will they
be
be
on
on
time?
time? I
You were
feel like we've
exactly on
cracked
time.
the on time part.
Yeah.
Yeah, I think that's a thing that we now do on a regular basis is show up on time, which is huge, I think. People should really reward us somehow.
It's a thing to aspire toward.
Yeah. How do I turn that off? Okay. Uh, so I want to show you. So, hey, everyone. We exist. You exist. We think, therefore we are. So I'm Fraser Cain, of course, publisher of Universe Today, host of this channel. And this week, I've got my buddy, co-host of Astronomy Cast, Dr. Pamela Gay. Pamela, how's it going?
It's going well. I have a crazy new angle for my camera today
Yeah.
because you get to benefit, unlike every other stream I've done for the past 5 days, from this being on a new used computer because mine died.
Oh, poor computer. Um, So, man, so for people who don't know who Pamela is, then it's time for an education, everybody. Pamela, of course, is an astronomer, a PhD astronomer, Dr. Pamela Gay. And Pamela and I have been doing the Astronomy Cast podcast for 10
Almost
years now.
12. No, 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 no.
What?
Yeah, we started in 2006. We're at 11 and a half years right now.
Okay. I think of the number as 10, but sure, 11 and a half. So we're wrapping up season 10, season 11.
We're wrapping up season 11. We start season 12 in September, and we pretty much start it with our 500th episode.
People are saying
Go
you're a little
us.
loud, so I'm going to just bring
Yeah,
down your
I'm
audio a little more.
backing away.
No, it's okay. It's okay. I got all the control. Please let me
Cool.
know until we're at an okay level.
We're still getting all of our stuff. Well, I'm still getting all of my stuff set up.
Yeah. So let's talk about before we get on to so the purpose here, Pamela, PhD astronomer, she's here to answer your questions about space and astronomy with me. But let's talk about Astronomy Cast episode 500 before we
Oh
can go
my
any further.
gosh.
Yeah.
So this is it's one of those things where when you just do a weekly show and go on hiatus in the summer for sanity like we do, it always seems like it's so far off because it's 12 years off. And we're hitting that point. And to celebrate our weekly Space Hangout crew, this is the group of fans, friends, mods, people that we rely on for all the different programs that Fraser and I do across all of our different media empire thingies. They have organized a celebration, 2 days, Saturday, September 15th. We are going to be at the Recess Brew Pub here in Edwardsville, Illinois, drinking, sciencing, eating, sciencing, more sciencing. Then after dinner, we're going to, weather willing, go to a star party. Somewhere in there, we're going to do a live Q&A with Fraser. Dr. Morgan Renberg is going to be making a stop. And then on Sunday for the big 500th, we're going to go over to the historic Wild E Theater, which is directly across the street from the brew pub. This is a small town. And from that great little stage, we're going to record our 500th episode. And we hope all of you will be there.
500th. Okay, thanks everyone. I brought the mic level on Pamela down a couple of times, so let me know if that's a little better. All right, so I want to show you guys something now. So check this out, and Pamela has no idea what it is that I'm pointing at, but I'll have to explain it for her. Let's see if this works. All right, so I'm going to see if I can zoom in on this here. All right, so what you're looking at here, let's see, let's make it even bigger. All right. All right, there we go. Okay, so what you're looking at here is a telescope. And so this is for the return of the virtual star party. This is a 130 millimeter I forget the name of the telescope, but it's apparently super good with a really fancy color camera connected to the back of it, and it's totally um, available via the internet. And so we're going to be bringing back the virtual star party, and as sort of the backbone of this, we've got access to this amazing this amazing telescope that will allow us to kind of peer through the night sky really quickly. So, and then all the other stuff as well is the plan. So I just wanted to sort of show that to everybody. Let's see, is it this one? Is it this one? Okay. So I'm going to be doing some tests and probably doing some like live streams shortly. So a big thank you to Oceanside Photo and Telescope. There, Dustin Gibson, who runs the company, set up this amazing setup that we'll be able to use. And so hopefully in the next couple of weeks, I'll start doing some live streams with folks, and you know, show you around the night sky. We'll view some galaxies and some dark nebulae and some star clusters and the planets that are up. So I just wanted to sort of show you things are moving forward. I promise we're gonna figure this out.
And I really hope to eventually be able to join you. But I fear I bring clouds every time
Right.
I've planned to go out with the new telescopes that we got from Oceanside and from Celestron. We have had the most amazingly bad weather here. Uh, it's it. I went camping this weekend and we got rained on.
Yeah.
Yeah.
So let's get into, so the purpose of this really is to get everybody's questions, because we're always so busy with all of the various shows that we do and we don't really get a chance to answer a bunch of questions. So let's, you know, I'm just going to hit you with questions from the viewers and try to elaborate. As always, I like to make the question a little harder if I can. So, you know, so let's go on. So Ziben Molnia asks, Molnia, is that same as the orbit? Anyway, how would a direct collapse black hole collapse without becoming a star first and blowing away infalling matter as it exceeds the Eddington luminosity?
So, if I'm understanding the question correctly, in those instances where a massive object or a massive cloud of gas and dust is collapsing straight into a black hole, bypassing GO, not undergoing regular nuclear synthesis. This is one of the models for how supermassive black holes in the centers of galaxies early in the universe formed. How is it these are able to form without igniting as a star and thus ending the collapse prior to the black hole? Am I understanding the question?
Yeah, so they like a direct collapse without becoming a star first. You know, you've got it sort of coming down together. How can it actually form and not sort of form a star, and then the stellar winds will blow out all the material and stop it from collapsing?
So, the few times that you can end up with objects like this actually occurring, you're looking at not the 80 to 100 solar masses, which appears to be the maximum size that a star can form at. And these are stars that in their end days will become black holes. But rather, we're starting to look at the tens of thousands to millions of mass black holes that you have at the centers of galaxies. This is a yeah, I guess product is the right word. This is the product of a very turbulent collapse. So, what is happening is instead of having this nice spherical collapse that you may be imagining in your head, the models actually show, and the people who figured this out got all sorts of awards for it. This is not something I know all the details on. Um, but as this is occurring, you have turbulent inflow of material, and there's so much gravity that it basically you might have had a star inside the event horizon at some point, but so much stuff comes together in such a tiny volume, and it's the rate at which it occurs that allows it to just, there's so much stuff here. Hey, we're a black hole now,
Yeah.
guys.
And one of the
It's
things that we were talking about this in our supernova update over on Astronomy Cast, and one of the things is this idea of an unnova, right? Like there are these supernova that the material falls in at like 70% the speed of light, and then it like bounces off the middle as it's collapsing
yeah.
together, and you get these outflowing, you know, explosion of energy, and that's the supernova. But in some cases, this pull of the gravity is so strong that the thing just literally implodes. It goes pop, and it's gone
Yeah,
completely. And so they're calling it an unnova, but I've decided it should be called a supernova.
I go for that. I'd
Right.
go for that.
Yeah. Um, Jim LeGraff asks, how do you know exactly where a radio telescope is pointing? Is the field of view a point, not an arc?
It is actually pretty much, we call it a footprint most of the time. So you have a pixel with a radio telescope. You can set it up the feed so that you're actually looking at more than one place at a time, but in general, the way radio telescopes work is you point your one radio collector at the sky and you scroll it across. And in order to know exactly where you're pointed, just like with any telescope, you have to, well, align your system. And the thing that we use to align most systems nowadays is quasars and standard stars. With quasars, we actually have the ability to align things that are visible across many different wavelengths, because quasars kind of like to give off light in pretty much every wavelength. Point an optical telescope at a quasar, you can see it. Point a radio telescope at a quasar, you can see it. And it's off of these fixed reference points that we're able to figure out if we're looking at what we think we're looking at.
It's people don't like my dad joke. I'm a dad. It's my job.
It's true, you are.
Yeah, so it's a funny thing. Like with an optical telescope, they just take this big view of the night sky and then you get a photograph. But with radio telescopes, they have to like scan, individual little tiny chunks of the sky. And I know with some of the bigger telescopes, the amount of pixels, they can do 8 or some larger number, but it is still scanning these tiny little chunks of the sky.
Often the way you do this, and actually I had a summer internship like so many college students do, and mine was to write a control system for a radio telescope out at Cape Peak. And what I didn't know going into this was quite often what they'll do is a footprint, then another footprint, and they have to optimize to take a picture that's basically in the old comic book style of you have a grid of dots that builds up your picture.
Yeah. All right, this is a good one. Let's talk about virtual particles going into black holes. So Zior asks, inside black holes, do virtual particles pop in and out of existence? And if so, and they were pulled apart, wouldn't that add mass to the black hole to the point to negate the effect of Hawking radiation? So there's kind of two questions in there, right?
Yeah.
One is, do virtual particles... before we even go to that, what are virtual particles?
Virtual particles are the universe saying this blob of energy would like to be matter now, please, and spontaneously converting a bit of energy into a bit of matter and a bit of antimatter that exist momentarily and then annihilate upon one another. And this is happening all the time so quickly that we're absolutely unaware of it. But It is just that interchange between matter and energy.
And if I understand correctly, there's this experiment called the Casimir effect where you take two plates, you pull them really close together, and essentially the size of the wavelengths that can form outside of the plates is bigger than the size of the wavelengths that can form inside of the plates. And so you get this pressure that pushes the plates together, and you can replicate that. So
these are real.
So these things are real, absolutely.
Yeah.
And so then the question, half of the question is, would they be appearing inside the event horizon of a black hole?
So this is where I have to say that in general, the answer to any question involving what happens inside of a black hole is, I don't know. But given how far the event horizon can be, how big it can be in the case of some of these objects, my observational astronomy stomach wants to say probably, but again, this is my observational astronomy stomach that I'm listening to. Now, the reason that I'm willing to go there is because the idea of black hole evaporation requires there to be virtual particles that are appearing right at the event horizon. So if they're occurring right at the event horizon with one particle in and one particle out, like a bad game of hokey pokey, this leads me to believe that you should have virtual particles that are forming just inside and entirely just inside that event horizon. Now, with Hawking radiation and black hole evaporation, you have these two particles that are made up of the energy that's in that region of space. And the two particles come into existence, and the one particle flies away with its energy and thus its mass, because they're the same thing. And the virtual particle that formed inside the black hole, it's not adding or subtracting anything to the black hole. It's just part of what was already there. And if you have virtual particles that occur only inside that event horizon, they're just going to be made of mass that the black hole already had in the form of energy. It's just this flip between states.
Yeah. And I've mentioned on several times sort of, to explain why the black hole, as the, while virtual particles are falling into the black hole, it actually makes the mass of the black hole go down, right? And it's just, from an outside perspective, you're seeing energy coming off the black hole, and you can't have that, so the black hole has to give up the mass that makes up that energy.
And the reason that we don't actively see all of the big black holes that are out there, these things that are 4 solar masses or bigger, up to millions of solar masses, is all of these objects have an event horizon that's sufficiently large that energy from the cosmic microwave background falling in is more than sufficient to counteract the amount of mass energy that's being lost through Hawking's radiation. So blame it on the cosmic microwave background that Stephen Hawking never got his Nobel Prize.
Yeah, the only way to kill a black hole is to stick it in a refrigerator. Right? Just cool it down to almost absolute zero. That's the best you can do.
Or just make sure there's nothing around it.
Aaron C. says, any update on Eta Carinae? Eta Carinae?
It hasn't. Eta Carinae.
Yeah. Has it exploded yet?
No.
No.
I'm sad.
Okay. Yeah, anytime. Like, we would like
exactly.
a supernova visible. Actually, neither of us would be able to see it, right? I can't see it from here.
No, it's a southern hemisphere object. It's fairly near the Southern Cross, if I remember correctly. It's a gorgeous system through a telescope. And what's amazing is it became what it is since, well, some people in this feed's house was built, I suspect. This object, just a few hundred years ago, underwent a fabulous, not a supernova event, built this amazing nebula around itself called the homunculus.
Yeah.
And now we're just waiting for it to go boom.
All right, this is an interesting one. So the capacitor asks, if you fell into a black hole, wouldn't the event horizon recede away from you the closer you get? Because you'll experience time dilation as you approach light speed, so the black hole would evaporate. So I guess it's like, and I think there's sort of a misunderstanding about how the time dilation is going to work from the perspective of a person falling into the black hole, as opposed to someone watching that person fall into the black hole.
So the person watching the black hole will, and this actually starts to get into the ugly philosophical parts of cosmology that make me want to run out of the room screaming.
Okay.
No, I won't. Especially since I don't think I can get out of my chair the way my desk is. So with a black hole, as you fall in, you go faster and faster and faster. If you have a sufficiently large event horizon, you may have a long time to go between falling in to your death and actually hitting something or being spaghettified or otherwise undergoing things that will kill your brain. Now, once you get going fast enough, time will slow down for you. And so here's where it becomes a philosophical question. To an observer outside looking in, it may appear that you're getting redder and faded and redder and faded. as you essentially stop.
Right. And it's not
But
because you're moving faster than the speed of light. It's that you're in such a incredible gravity well that you have time dilated to infinity from the
now, to
perspective of an outside observer.
exactly.
Yeah.
Now, as you accelerate towards that black hole, uh, this is where it also starts to get ugly because uh, what comes first, the spaghettification or the time slowing down? Now, it won't recede from you. The question is, uh, do you get to live long enough to get to experience watching time slow down, essentially, or do you just die?
Right.
So
But
you
you
won't see the black
experience,
hole.
as the person falling into the black hole, you get to experience every painful, horrible moment of
Yeah,
your
don't try this at home,
infall. Yeah.
folks.
Yeah. I mean, now you may see the universe accelerate out there as you fall into the black hole, but you experience time in real time, which is the whole point of time dilation. You always experience time at 1 second per second. It's just that
Yeah,
you see other people experiencing different amounts of time.
yeah,
Yeah.
it's death.
So Arjone is asking, this is great, right? How long does a black hole live from its perspective? Is its life instantaneous or infinite? So think about this.
So,
Like
so
it's
for
yeah,
a photon's life is instantaneous. It lives and dies the exact same moment as far as the photon is concerned. Now, a star is just hanging out, going, I'm a star, moving through the universe. And its perspective of time is directly related to how much it's being accelerated. So time slows down as a function of acceleration. Now, time also slows down gravitationally. So we have this gravitational shift, which is why we perceive GPS as having a slightly different time. Um, I'd have to do some looking things up to get at, does a black hole not have time or not? This again
yeah.
gets into the philosophical region.
And
So,
if it evaporates eventually, right? Does it begin
yeah,
its experience? It then evaporates away and dies, and it doesn't experience any time because the time dilation is so ferocious.
yeah.
And do different masses of black holes, are they going to experience different amounts of time dilation depending on their mass? Yes.
Well, so I think once you're inside the event horizon, all physics is off.
Yeah. Yeah. And I guess
But
that's the part, right? Is you say, can you tell us its mass? Can you tell us its rotation rate? Maybe you can tell us its charge. That's all you get to know. If it's not one of those three questions, then we don't know anything else. But it's a great idea. I mean, that idea you brought this up in Astronomy Cast. This idea of the photon moving, that a photon doesn't experience any time, and it's just like
yeah,
blows your brain when you think about what that means. And in fact, there's some theorists who think that all light in the universe is the same photon, like because it all can because a photon can turn into matter and matter can turn into photon, and so
right.
in theory. But anyway, I think it's great.
So, and this is one of those things where neutrinos are kind of like your great science fiction toy because they're traveling at very, very close to the speed of light. And they have the magical ability, it's not actually magic, it's just super cool. They have the ability to transition between their velocity into their mass and their mass into velocity to change identity. And so imagine if you wanted to suddenly be someone else, you just had to go faster or slow down.
Yeah,
And neutrinos do all of these things. So one particle will change velocity and identities as it travels from the sun to the earth. And that's the one I want to know the details on.
yeah. Jim Becker saying, "Are you saying that black holes can die?" Yeah, black holes evaporate.
Oh yeah, totally.
So over incomprehensible periods of time, black holes will evaporate and disappear, which is an enormous problem for physics.
And where I get confused with the black hole question is the higher you are away from a gravitational source, the longer a period of time you experience. So we're experiencing time faster than the GPS. If you could get down closer to the Earth's center of mass while collapsing the Earth down underneath you, you would experience time even faster relative to the GPS, because your time is getting slowed down. It's the Buck Rogers problem.
I didn't know it was
So
described in physics as the Buck
I
Rogers
don't
problem.
know how else to explain it. But with a black hole, the question is, do you slow down to the point of stopping once you're inside the event horizon? And I don't know. And now it deeply bothers me. I shall be like asking Sean Carroll or something.
Yeah, we should. I'll get Sean Carroll on next time.
Observational astronomer.
Yeah, not astrophysicist. Yeah, yeah. All right. Philip Anderson asks, when will the James Webb Telescope launch? May 2020.
I'm just going to blink at you.
Yeah,
That's all you get.
yeah, yeah. Um, will it launch in May 2020? Just depends if that next shake test that it goes through doesn't shake any more spare parts loose,
And as long as it's not like stored somewhere that gets hit by a category 5 hurricane, that had no effect whatsoever on James Webb,
Yeah.
except for the timelines. It only affected the timelines. But yeah.
The 12th of never. No, it is going to launch over
I hope,
budget,
right.
not on time, but it is going to launch.
Yeah.
Marco Tosic says, are there any updates of the black hole image that is expected this year? I've heard
No.
spring next year, which is a lot longer than I was expecting. I
saw a press release on how they're adding new facilities for future data.
Right. But somewhere there's some really important databases that are being crunched right now.
Yeah. As I've said on Astronomy Cast, the thing about the Event Horizon Telescope is they were combining light from a variety of different radio observatories, and you have to get the timing exactly right on this.
Yeah.
So some poor sod out there is going to be tasked with trying to line everything up in time. And not everyone's atomic clocks will have worked the way they thought they worked.
Now, I just did an episode all about the next generation telescopes that are going to be incorporated into the 2020 decadal survey. The HabEx, the Lynx, the Origin Space Telescope, and the LUVOIR. You were on the decadal team last time to help.
Yeah.
You were on one of the committees to help bring together some of the recommendations.
Right.
How well did your recommendations survive to spacecraft, or are the spacecraft still even being built for the recommendations?
So the committees I was on didn't deal with spacecraft. We dealt with the wellness of the community and growing the community.
Right.
But let's see if W First survives the 2019 congressional budget. Currently, it's doing fine. So as long as we can so we got Curiosity out there. Curiosity did its thing. We got Europa Clipper still going. That was another thing. ALMA's doing its thing. Although ALMA started doing its thing well ahead. It was mostly a don't destroy ALMA. Now we just need JWST to leave the planet.
Yes, please.
Leave the planet. Sorry, all of your eardrums.
Yeah.
Yeah.
I just saw a paper today about an enhanced version of the Very Large Array that they're thinking of building. So an upgrade of the
building or upgrading
the Very Large Array. Yeah.
Yeah, they
the one
have
that's
to
in
update,
New Mexico.
Yeah, so VLA gets updated every N years, where I think the last major update they did in the early 2000s when it was 25. So now as it starts to near 50, which is a bit terrifying to think about, as it starts to near 50, it's another time to start updating the system again.
Jurij Slavic asks, the Great Attractor, how can it be and how many of them are there?
Well, it's just a matter of statistics. So, the Great Attractor, there's nothing exciting about it other than its name. It turns out that the disk of the galaxy we live in, we can't look through the gas and dust real well. So, as we look out through the disk, there's this swath of sky that glows. This is the Milky Way we talk about. And anything located on the other side of that disk, we just can't see because its light is blocked. And the Great Attractor is nothing more than a supercluster of galaxies located out through the disk, and we see things above the disk going down towards it. We see things below the disk going up towards it, go off the angles. We see things going towards it, and it just works out that the statistics said, given our 360 wraparound galaxy, not 360 degrees around the sky, not filling the full volume, not 2 pi. Given this entire swath going around the sky that we can't see, one of those swaths that we can't see just happened to include a massive object gravitationally attracting things into it. This is common. We're getting sucked into the Virgo supercluster, and that sounds far less exciting than if I said we were getting sucked into the Great Attractor.
Yep. Now, Mike McHugh is saying, what other channels should I be watching to learn more about the universe? I'm starting from zero knowledge. Might I recommend a podcast with my co-host, Dr. Pamela Gay, called Astronomy Cast? We're about to celebrate episode 500, and it was made precisely for what you're looking to do, which is that every week, Pamela and I pick a topic about from space and astronomy, and we just build on the topics one after the other, a different topic every week, and we've been doing this for apparently 11 and a half years, just about to hit our 500th episode, and I know that when you sort of listen to some of those, you will enjoy them. We have thousands of 5-star reviews on iTunes, maybe 1,000.
Please go review us on iTunes.
And we are much beloved. So, and it's all thanks to Pamela's mighty brain.
And actually no, Susie and Nancy's organization and your skills, question asking.
Yeah, exactly. And my just boundless curiosity. Quack Quark asks, with increasing gravitational wave detection sensitivity, what other astronomical events could possibly be detected?
So we're hoping to be able to start detecting neutron star collisions that are smaller, maybe white dwarf collisions. This is something you may be keeping up to date better than me with Lisa. My general philosophy is spacecraft are dead to me until they launch. Right, whereas he actually pays attention to them prior to launch.
Kind of obsess about them. Yeah,
it's okay. Yeah. It's okay.
Yeah, that you just can't have your heart broken anymore. Well, I don't mind. I still haven't been beaten down to the point now where I
had a Japanese X-ray satellite that I needed for my dissertation blow up, or at least cease to function on takeoff. So when what you need for your dissertation does not become a working observatory, you learn not to rely on things that don't yet exist.
Yes. Let's see. Okay, Frankie Terza asks, Fraser and Pam, what are y'all's opinions of panspermia? So explain panspermia.
Okay, fine. So panspermia is the notion that it is possible to splash biologicals from one world to another. So you hit the Earth hard enough with an asteroid, which is something that happened to the dinosaurs, and material gets blasted into space by the shock wave. In the case of the asteroid that hit the Yucatan Peninsula, we had rocks, vegetation, and very quickly, very dead dinosaurs launched into outer space. Now imagine if one of the rocks that was launched during this process happened to have deep inside of it various life forms happily gnawing away on the nutrients inside the rock. That rock could have traveled to another world and infested it with tardigrades or other hard to kill life forms that exist on our planet. Now, the other side of this is our world was hit over and over and over again by asteroids during the age of heavy bombardment. And when this occurred, who knows what got here? It's possible that life evolved on Mars first, came here second. It's also possible, as we now know from objects like Oumuamua, that we have alien rocks visiting our solar system now and then. And who knows, maybe one of these is splashed into space when some alien dinosaur decided to bite the dust the hard way.
Yeah, I mentioned this. There's 30,000 potentially interstellar asteroids passing through the solar system right now. It's estimated.
It's
So,
kind of cool.
yeah, I always think about this like if asteroids can make the journey from star to star, we should be able to too, right?
Well, they
And
do it very slowly. We'd be very dead before
you
we
know,
got somewhere.
just live on an asteroid. I know this is your plan.
Yes, it is. It's a dream. I don't know if it's a plan.
Um, question. Let's see. Question there from Yorn Albert. What's up with TESS? Should it start sending data? TESS has already sent data. They've already been sending back pictures to Earth.
They've been doing a shakeout on its cameras,
Yeah,
essentially. Twitter's the best place to follow this
yeah.
one.
So TESS is already sending back data, but the problem with it was the same problem with Kepler is to actually find planets requires fairly long observation times because you're looking for not just a single detection of a planet passing in front of the star, you want to see two of them, right, which then tells you where the planet is. So patience, it's going to happen, don't worry.
And and with telescopes that are searching for planets, you also have to calibrate them at a level that we don't generally do. So the amount of calibration time that they're going to spend in making sure they know exactly how every single pixel on their camera is functioning in space, the time they spend making sure they've fully outgassed, looking for any internal light scattering, all of that. It's it's a thing, and they've been updating on Twitter about all of the calibrations they're doing as well.
Um, but just to go take one step back, we actually didn't answer the question about the panspermia. So
Oh,
what do you think? Do you think panspermia is a legit way to explain where life on Earth came from? And do you
I
think
don't think
that it
we
would?
don't know enough.
Yeah. And so if we found life on Mars, would we be related?
So first of all, life on Earth has existed multiple times. We know there was first of all the methanogens. We don't really have genetic material from the methanogens. We know that there was a initial Precambrian life boom of things that gathered nutrients pretty much through their skin. I can never remember the exact pronunciation of this flare up of life. It begins with the letter E and is very hard to explain. And there are beds of fossils in Nova Scotia, in I think Namibia and Australia. So this was a boom of life about 500 million years ago. Then there was a second called the Cambrian boom of life. And this was where we suddenly had life forms that did have mouths, and it's strangely much easier to survive and outcompete your other critters when you have mouths. So if we can get life of three different kinds booming on our world, I wish we had genetics of the methanogens, we had genetics of the Precambrian life, so that we could say, yes, this all has the exact same, or this all has entirely different genetic makeups. So if we do find life and we can somehow get genetics out of it on Mars, if it exactly matches our genetic makeup, if it has the same uh, different materials tied up in it, the urine, thylacine, guanine, I don't think that's right. If it has the right amino acids and nucleotides to match the kinds of things that we have on Earth, if it has the same right-handed chirility of what chirility of what we have here on Earth, we might be able to say this is life that appears similar to what we have on Earth. Therefore, it is within possibility that we have the same origins. Now, if it's something completely different, all we can say is it's completely different from
Right.
what's alive right now.
Yes. So the best actually there's kind of two best case scenarios. One is that it is related to us and we can identify when we branched away from this other life form, when was our common ancestor,
Yeah.
that would help us get a sense of when maybe the panspermia did happen. The other possibility is that there's no similarity at all, which is even more fascinating because it means that life formed independently on Mars. And then it makes the Fermi paradox even weirder, which is like, well, if life can form on two planets in one solar system, why don't we have life elsewhere in the universe?
Well, and this starts to become what is the rate of intelligent life getting the chance to come into existence? If we hadn't had an asteroid swoop in and beat up the dinosaurs the way it did,
Yeah,
if we hadn't had all those other extinction events,
yeah.
and as we're currently undergoing a massive extinction event, that may explain the Fermi paradox.
All right. Hey, move some questions. As Nightbot is saying, put a question mark in front of it to help me notice them. But Todd Larson says, "I hope we don't find life on the sun. They would be technically be indestructible," which I think is
Luckily, I don't think we have the
yeah.
technology to get there from here.
And Dave Sims notes that it takes 3 transits to confirm an exoplanet, not just 2.
It's
Yeah,
true.
yeah. 2 gives you the hint. 3 gives you the confirmation.
And the three
4
have to be
is even
uh,
better.
equally spaced, basically.
Yeah, yeah, because that's what you need to have those, just that regular event to rule out anything else that could be happening, like, an alien spacecraft passing in front of the star, an alien megastructure, some kind of
You
alien.
just like Tabby's star a
Yeah,
lot.
yeah. Um, Bob Woodward asks, "What are the chances an alien civilization existed during the time of the dinosaurs?"
I don't know.
Yeah, there you go. I mean, and I just did an episode on this, Bob. So, which is like, there's been a couple of really interesting research that was done. One, just like, if there was an industrial civilization that came, say, millions, billions of years ago, what kind of evidence would we find? And there could be evidence in the geologic record. If it didn't show up in the fossil record, it could show up in the geologic record, and there could be some kind of evidence that there was a past civilization. And so far, none has been found.
Yeah.
But if it's short enough, then it would just come and go, and you wouldn't maybe not even see it in the fossil record or even the geologic record. So who knows? Um,
And while you scroll, I'll just add, and there's gaps in the geologic record that we're still filling in. And what's amazing is that we are able to slowly fill these in.
so one thing, and the other thing we might be looking for is some kind of structure, or I don't know, memorial on, like, the moon. Some kind of monolith that could be there. And so I finally saw 2001 again. I don't know if I mentioned this to you, that it traumatized me as a child. Yeah,
No.
yeah. I was like 6 years old, and I watched
Oh,
2001, and it freaked me out.
I,
And
I was in fifth grade when I saw it the first time on Betamax. On
yeah, I was
Betamax.
yeah, I was 6, and Carla was like, "We should watch it." So we watched it, and now I'm just confused,
Yeah,
like
that's a
everybody
valid
else. Like, that's the
response.
that's the normal response. Before I was terrified, and now I'm just confused. So I think there you go. All right, Ghost World asks, "What do you think would be the bigger scientific find? Already intelligent life relatively close to us, or the knowledge of how and where the universe was formed? Which would you prefer to know?"
Well, the where the universe formed is everywhere. We've got that answer. How it was formed, it tells us whether or not there's a god monkeying around, and so that kind of a philosophical question, I think I'd rather have.
Than the location of aliens relatively nearby.
Because that we may find on our own
Yeah.
someday. Science is currently pointing towards we will never have an answer to what was the initial cause that made our universe come into existence. Although there's some interesting ideas. Larry Suskind's book Cosmic Landscape does a really good job discussing this, and it Yes, knowing what exactly made the universe exist would
You'd like
help
to know the
many of our
answer to that.
stomachs.
That would be
Yes, and my
helpful.
phone is agreeing apparently.
I think I'm going to agree with you. I think that was a really good answer, and I think I concur. If you had asked me first, I would have wanted to know about the aliens, but I think that knowing, because as you said, we can kind of find them later on.
Yeah, we'll
Um,
figure that one out. This is
yeah,
what TESS is for.
yeah, that's good. So I would love to know what people's terrifying movie was when they were 6 years old. What was the movie that you watched?
Watership Down.
Was that yours?
Yeah.
Yeah.
My parents thought it was just a cute little cartoon movie. No,
Yes.
they killed those rabbits.
Yeah, it was pretty gruesome. But it didn't.
Yeah.
I was about the same age as well, and it definitely was traumatizing for me as well. But I don't know if it wasn't as scary and didn't sort of haunt me in the way that 2001 did.
Yeah, that was like one of the few books in high school I was like, absolutely not reading that. You can't
Yeah.
make me. I'm going to go read a much longer book.
Arjone asks, do you think humanity will make it to the end of time, like black hole farming time?
No.
No. I mean, it's just like, just run the odds, right? No. Chances are no. We're not going to make it.
It's there's a Doctor Who episode that has the actress who plays Arya on Game of Thrones, and it is one of my favorite Doctor Who's. It's a back to back where he gives immortality to a human, and they watch the universe end together.
Yeah,
Go watch that for a beautiful take on this.
that's cool.
And they're now singing songs from Fiddler on the Roof in chat.
Well,
I
no,
love
that was
all of you,
one of
but still.
theirs. That was their terrifying movie.
Oh,
So
Fiddler on the
there's
Roof.
some great ones in there. Return to Oz,
I can totally
Poltergeist.
see Neverending Story.
See,
Poltergeist, you should not have been allowed to
I
watch.
refused to watch Poltergeist when I was a kid. So a bunch of my friends wanted to watch it, and they freaked themselves out, and I just wouldn't do it. Jabberwocky, RoboCop, Aliens when I was 8 years old.
Oh
Yeah,
yeah, I didn't
yeah.
watch any of those till I was in high
See,
school.
for Aliens, I was the perfect age. I was like 15 years old, and I watched Aliens, and it just blew my mind. It was like it was Space Marines and aliens. Oh, I really, really liked it. So, yeah, that was my favorite movie. It looks like Pamela has frozen. We'll see what happens. Um, Okay, this is a great question. So, Chit Ranjan Baghi asks, "What planet size can be considered a gravity prison?" And that's a great question. And in fact, so the question is like, what's a planet that has too much gravity to be able to to be able to allow space flight? And the answer is, well, there's two of me now. Let's see if I can shift to me fully here. Yeah, there we go. Wait till Pamela gets back. So the reality is that you could launch spacecraft from a planet with twice the mass of the Earth, or twice the gravity of the Earth. It would be a lot harder. You'd need like a Saturn V kind of rocket to launch the kinds of payloads that we do today. And you could go all the way up to, if you get to the part where you've got a planet with 10 times Earth gravity, then you're launching then you're needing like half the mass of your planet in rocket fuel. So we happen to live in a world, the amount of gravity that we have is about the most gravity that's possible to have a reasonably successful spaceflight program. If the gravity was very much stronger, it would be a lot of trouble. That's a great question. Yeah, double Frasers. Um, and I would love to know what was your movie that you were the perfect age for, the one that you just like. It's like someone had like special ordered you a movie. And so when I was like 10 years old, I try to remember. There was War Games, which I loved, and Tron, which I just couldn't get enough of Tron. And I've gone back and watched both, and they don't exactly hold up. So Bob Woodward asks, Fraser, if we made a clone of you, do you feel like you'd live on? Uh, this is sort of like, is a teleporter, as a transporter, is it a device that moves you? Is it a method of transportation, or is it a suicide booth? And in my opinion, it's a suicide booth. That if you hop into a some kind of teleportation system, it's going to tear you apart at an atomic level, kill you, and then rematerialize you at a copy of you at another location, and that's not you anymore. Now that person thinks they're you, but the you, the one that's seeing at your eyeballs, uh, originally you're not around anymore. So that's my opinion. I would never get into one of those infernal gadgets. Star Wars Highlander. Oh yeah, Highlander. That was great. Jurassic Park. Yeah, Flight of the Navigator. Man, those are some good movies. Let's see. So Bob, I would not get into a any kind of teleporting uh any teleporting device whatsoever. And I don't care how entangled the quantum is, I'm not going to do it. So, let's see if I can get the is that my monitor? No, I dare not try to see if I can bring this up. We'll wait for Pamela to try and return. Apparently, she's having some kind of weather problem, so it's just me for the next 9 minutes. And just in case she doesn't return, of course, you should join us for our final episode of the season on Friday. And then we take our summer break. Astro YYZ, is someone working on artificial gravity? Uh, no. Uh, Sort of. Not exactly. Um, so the only kind of artificial gravity that's going to be possible that we're aware of right now is some kind of centrifugal force or centripetal force, depends on your perspective. And so you spin something up and you use that the the uh, the the velocity of that spinning to provide artificial gravity. And there's been a couple of spacecraft that have been proposed. One is called the Nautilus X, which was going to be attached to the International Space Station, and it just never got built. And it wouldn't have been that expensive, probably about $4 or $5 billion, which I know sounds like a lot of money, but in terms of the International Space Station, it's not too bad. And that would have tried to help figure that out. It's possible that it's going to go to the Deep Space Gateway now, so we'll see, and it may show up, and that's going to be really our first test to know if some kind of artificial gravity is going to work. Now, Astro, why was it saying? Speaking of 2001, I did the math on the spaceship that was in 2001, that big orbiting space station, and based on the mass, and I think it was going to take 60,000 launches of the BFR um, to build that thing. So we should start a little smaller before we get to there. Ghost World says, how about you don't do that whole summer break thing? So we're going to be doing the summer break for the Weekly Space Hangout and Astronomy Cast. And mostly it's because there's a lot of moving parts to both of those shows. You know, with the Weekly Space Hangout, there's me, Morgan, Kimberly, Paul, plus Nancy and Susie to help with the coordination, and Chad to do the editing, and everybody just kind of needs a break. And so we take 2 months off. And same thing with Astronomy Cast. Now that I'm still going to be making videos, I don't think there's going to be any kind of break or change in the schedule. We're going to be still releasing Guide to Space. I'll still be doing the QAs. I'll still be doing my newsletters. We're probably going to be starting to do the virtual star parties again, but it's just those two shows. We just take a break. Well, Pamela is attempting to return.
I am.
She's a right now. She's just a blank screen on a bad phone. So.
I'm so sorry.
It's okay. It's okay. I will properly send people to the various places where they can find out more and see what you're up to. Yeah, this is just hilarious. Let me try and bring you back here. There she is on a little screen on her phone. What a Herculean effort.
I'm trying, and I have to admit, my poor phone is on cellular. Our entire house lost internet.
Oh.
Yeah, so there's a storm coming. I don't know if they're related. I'm going to blame the weather.
Um, Space TV asks, "Am I still going to do the open space live streams?" Yeah, I some of them, and I will probably still try and find some guests. But I'm going to be in Australia in a week and a half, so that's going to be sort of, and the wife and I are going to be. I'm doing the keynote for, oh man, a space conference that's happening in Australia, and then we're going to be traveling around Australia. So my internet's going to be pretty shaky. So, but when I get back, I will jump back into it and make all kinds of good stuff.
And while he's traveling, I'm home and I'll be doing the Daily Show over on Twitch every day at 1 p.m. Eastern, 10 a.m. Pacific, 6 p.m. Europe. And about the time he's getting home, I'm taking off to go to the International Astronomical Union meeting, and then a whole slew of trips after that, but not until after the 500th episode.
And this is when you vote back in Pluto as a planet, right? At the IAU.
I I haven't noticed that that's something we're voting on yet, but as soon as I
Right.
get the list of questions, I'll let everyone know.
Yeah, that was when we started Astronomy Cast. That was right after you guys killed
You got.
Pluto, and now.
I was not yet a member. I was not
Oh,
yet
really?
somebody you could name. Yeah, I didn't become a member until several years later.
Jupiter says there's no internet in Australia. All right, well then I won't be doing anything from Australia. No, hopefully I'll be able to get a copy of my presentation that I'm doing. It's called Star Stuff, and it's going to be just south of Brisbane, um, just in early July. And my talk is going to be the golden age of astronomy. So I'm going to talk about all of those new observatories, all of the new cool, the image of the black hole event horizon, what the Large Synoptic Survey Telescope is going to be doing, and what a lot of these really kind of easily accessible technologies that even regular people can get their hands on these days. So that's going to be what my talk is going to be about. But I'm going to try and get a copy of it so people can see it. I'll see if Dylan is going to be recording it.
Cool.
Um, let's see.
I'm going to live dangerously and try and put my phone down because my arm is getting tired.
Will I do the
There.
TSP? What is the TSP?
Texas Star Party.
The Texas Star Party?
It's in May each year.
No, I haven't been. I haven't.
If you ever get invited, it is one of the most amazing star parties.
Sure.
I highly recommend it.
Sounds good. My wife's from Texas. Astro was saying winter in Brisbane is not too wintry. If you go further south, take warm clothes. Yeah, I'm going to be going north. So it's going to be like 25 degrees in the wintertime. So I can handle that. It's perfect.
The most expensive pair of socks I ever bought, I bought in New Zealand because October in New Zealand was not as springy as I thought it would be.
Um, all right. Well, why don't we start to wrap things up here? Apologies again for Pamela, tiny Pamela. You're this adorable little guest down on the screen there. Um, but we've got the last episode of Astronomy Cast. We've got the 500th episode, which if you want, you can come and join us live and watch us do the show.
Get your tickets at astronomycast.com. Click on trips, and it should be obvious from there.
Yep. And then of course you're streaming like crazy on Twitch as well.
Yes. So I'm streaming both as CosmoQuest, which is my day job, where you can check out the daily space Monday through Friday, except on holidays, at 1 p.m. Eastern, 6 p.m. London, 10 a.m. Pacific. And then we do a variety of other shows. And then I personally am on Twitch more and more evenings to talk about science in, well, lots of different places in society, science and art, science in movies, and well, just stop by Star Strider on Twitch and see what I mean.
Fantastic. All right. Well, thanks everyone for watching. Thanks to the mods for sort of staying on top of the
Modding.
conversations, for modding. Thanks as always to the Weekly Space Hangout crew. If you want to join this community, go to wshcrew.space. Thanks to Pamela for dealing with bad internet and still making it back. We really appreciate it. And I will see you all next week. I think we're going to do one more open space, and then I'll be gone for probably a couple of weeks. So thanks, everyone, and we'll see you all next week. New question show dropping tomorrow, and then in situ space utilization, so all about living off the land in space, comes later on in the week. Chad's working on that. And then the next episode is all about space navigation, and that's actually in the can, and now Chad's going to start editing it. So lots of work going on. All right. Thanks, everyone. We'll see you all next week. Thanks, Pamela.
Bye-bye.